Hi there, welcome back to the channel. I'm the GCSE science teacher, and in today's lesson, we will be learning about gravitational potential energy. This is part of the energy topic in GCSE Physics, and the content covered today will include calculating gravitational potential energy. So let's get started. First of all, what actually is gravitational potential energy? Well, it's the amount of energy gained by an object that has been raised above the ground level, and it can be calculated using the following equation. In the GCSE exam, you will be given this equation, but you should get used to using it and also manipulating this equation so you can rearrange it if you need to. Gravitational potential energy, also known as EP or GPE, can be calculated by timesing the mass of an object in kilograms by the gravitational field strength, which is in newtons per kilogram, times the height, which is in meters. The gravitational field strength, by the way, is just the amount of force that acts on an object on Earth or on another planet, but often in the exam it will be on Earth, and you'll be given this information in the exam. Also, as we are talking about energy, gravitational potential energy is, of course, measured in joules. This idea of potential energy often confuses students, I've found in the past, but just imagine that it's the energy held by an object because of its position relative to other objects. So, because this skydiver is higher and has a greater gravitational potential energy, it's because it's higher off the ground than the apple in this example. And that's what we mean by potential, really. That's all that that means. But try not to get too hung up on that phrase. So let's do an example. Calculate the gravitational potential energy of a zero point zero 0.02 kilogram paper aeroplane as it moves through the sky at a height of 10 meters on Earth. And gravitational field strength, or G, is 9.8 newtons per kilogram in this example. It's really important to notice how I have laid out this question. I have highlighted the key information, and you should do that in the exam to really focus your understanding. I've also written out the equation and then I've added in the numbers underneath the correct symbol. So 0.02 kilograms is the mass. 9.8 is the gravitational field strength and the height is 10. And then by calculating and timesing these numbers together, we get an answer of 1.96 joules. Don't forget to always include the unit and underline the answer. This way, your examiner will be able to see clearly evidence of your working out and logical thought. Here's a go for yourself. Calculate the gravitational potential energy found within a dancer who leaps into the air at a height of zero point 0.5 meters on stage. Their mass is 68 kilograms and they are obviously on Earth, so it's 9.8 newtons per kilogram for the gravitational field strength. Comment below. I'd love to see your working out and your answer here. Just like I said earlier, you may need to rearrange this equation in some way. Often you will be given G. It's very unlikely you'll have to work that out, but it's always good to know how to manipulate this particular, equation. You can use the triangle method like I've put out here. Just be careful using the triangle method if you are doing that throughout the physics curriculum, because as you get into more complicated equations, especially as you move into A level, the triangle is going to be a lot more challenging to actually use to rearrange. So just be aware of how to rearrange without the triangle. And if you would like a video on it, I'm more than happy to help you with that. Just let me know down below. But in the meantime, thank you so much for your time and thank you for watching. I hope that was a helpful video. I have been the GCSE science teacher and you have been curious. If you would like more GCSE content, feel free to follow me over on my Instagram at the GCSE science teacher or check out my channel for other quick fire videos that can help you with your GCSE exam for biology, chemistry, and physics. Take care and I'll see you in the next one. Bye.